Hi everyone, this is Federico, and this is my third video for the sleep apnea project for CTP1 unit. In the last video, I was talking about the Android Studio introduction and some explanations. And in this video, I will talk more in detail about the implementation of the code on Android Studio. There are a few updates on this last video. First, I will talk about the Android Studio tutorials and start implementing the real code from that tutorials to my Android Studio for my sleep apnea application. Secondly, I will talk about the little issue with my APD, Android Virtual Device, on my Android Studio, which doesn't work. As I said from the earlier video, I will create a new GitHub account. So I have just created a new account on the GitHub. So this is my GitHub profile, and inside here I have created a new repository for this project called Sleep Assistant. So if you click here, I will have to do a quick setup on my PC for this GitHub repository, which I will do it soon in the near future. So before implementing the real code into my Android Studio, first I will talk about the benefits of using the Android Studio compared to other IDE, such as Eclipse, for example. First, it is specially developed for building an Android app. It will have a faster development because the user interface is all about Android. The menu bars, the toolbars, that's why it will have a faster development. Compared to Eclipse IDE, which is a general IDE, it has a more general user interface. Therefore, it's not specially designed for the Android. The IDE can be used for many different programming languages. Secondly, the Android Studio has a Gradle integration. The meaning of Gradle integration is a custom build tool used to build Android packages like APK files by managing the dependencies and providing custom build logic. Third, it has a faster autocode completion compared to the Eclipse IDE. So generally when we develop the app, we will have a faster development. Last but not least, it is a stable IDE compared to the Eclipse, because according to DZone, Eclipse is simply Java-based software and a larger IDE in comparison with Android Studio. So it needs considerably higher amount of RAM space with a high CPU speed to function properly. Failure to meet this criterion causes Eclipse crashing and getting unresponsive. But this is not the case with the Android Studio. One of the useful features that I like about the Android Studio is the Android Virtual Device, which we cannot find on the Eclipse IDE. So this Android Virtual Device will simulate a real-world device and run your app just like when you run it on the real one. But one of the problems with this is that it is quite slow when you run it. So most probably I will use my own Android device for the testing. So now I will implement the real code to my Android Studio by following the link on here. But I won't click the link on here because it is quite slow when I open it. So I have opened it in my browser and just play the video.
That represents our MAC address. We can obtain a reference class.
So I will implement the code here on my Android Studio. So I've implemented the code from the tutorial into my Android Studio. And now I will explain briefly about the code that I've written here. So the first line here is just a MAC address of my MetaVer sensor. And these next two lines are just the Bluetooth Service Manager that is required in order to connect your Android device to the remote device, which is the metaverse sensor. On the next line, we have the service binder that binds the Bluetooth Service Manager from the built-in Android library into the metaverse. As you can see, the MW board that we talked before is coming from this variable, from the metaverse board class. So it is basically referring to this library, com.ambientlab metaverse board. Going back, inside the connection state handler in metaverse board, we have the two methods which are connected and disconnected. I'm not too sure what's going on here because I haven't read the documentation yet. But I think this overriding method should come from the metaverse library. So the method here has the same name as in the library, but the implementation might be different. So I guess the function of log.i here is to output to the console, as I saw in the tutorial video. It outputs to the console log, and if it's connected, it will output the connected to the console log, and if it's disconnected, it will output the disconnected. And the final code that we need to write is the mwboard.connect. This method call is used to connect the metaverse sensor with our application. And secondly, I will implement the accelerometer sensor data to set up a data stream of accelerometer sending live data from the sensor to the application. So I have followed the link and I implement the code into my Android Studio. So you include the try and catch exception inside the connected method that we talked before, but I won't explain one line by line because for this one I need to read the documentation. So I have created my first prototype for this sleep apnea project just to test the connectivity. So you put start button and stop button. Yeah, that's it. But I cannot test it now because I got a problem with my APD, as I told you before. So in the future I will implement the real UI on my project and put the functionalities that I want inside this user interface. Start expanding this prototype into the real application that I want. So in summary, continuing from my last two videos, there are some points that we have decided to use. First, I will use Android Studio as the application to build the sleep apnea app. Second, I will use a signal analysis tool called FFT, Fast Fourier Transform. And the third, use the latest user interface design for our app, like for example flat design or material UI, in order to make it more beautiful and more enjoyable to see. Fourth, we can use other useful libraries in the future if we need to. Fifth, we use a metaverse sensor which will be wrapped inside a strap, as I talked before in my first video. And the last one, I will use other tools that could be useful for supporting my project, like for example the vibrating motor for supporting my feature. So I have set a goal for this project. So my goal is to finish this project in time with the best result possible. So in order to achieve that, I have to finish building the project within 4 months. Second, in the summer break, I'll start doing and keep researching for the materials. Third, Research for the best and most efficient tools available. And last but not least, create a weekly deadline that must be achieved in time. So this is the end of my third video. I hope you enjoy it, and thanks for watching.